All right, hello everyone, and welcome back. This is lesson 14 in our polynomial unit. We are moving right along. Okay, in our last few lessons, we looked at the process of long division and how we can use it in order to divide two polynomials. And one of its major uses is using it to find factors of the polynomial. If a factor divides into the polynomial and you get a remainder of zero, you know that you have found one of the factors, and then the result from the division can then produce the other factors. So that produces one of the x-intercepts, and then you start to get a picture of the graph. Um, so what we're going to do now is use the long division process, in order to kind of put everything together. And um, now that we've learned about graphing and behavior, intercepts, multiplicity, and long division, all of it comes together. And as long as now you have a factor to start with, you can take a polynomial, have a known factor, divide it out, and then use that result to hopefully draw a complete picture of the graph. That's what all this is going to be about. And so this lesson puts all of that knowledge together. Okay, so let's get started. Let's start with a bit of a warm up. See G. G is a polynomial. Hi, G. Such a G. Anyway, here are some things that we know about this polynomial. Okay. It has a degree of 3. Both x and x plus 4 are factors of G. It has two horizontal intercepts, but only one of them is negative, and its leading coefficient is negative. Hmm, could we use that to figure out some different properties of G and maybe sketch what a graph might look like? Well, let's see. If it has degree 3 and we have two of the factors, then we can figure out what the third factor could potentially be. Okay, so let's draw a graph, right? So I suppose we should start there. And I'm going to do this. Let's just create a little axis here, and we'll just do that. I'll select my arrows, and here's my graph. Okay, let's mark off our graph. 1, 2, 3, 4. 1, 2, 3, 4. I'm not too concerned about the y-axis, because that could, the scale of that um, is affected by a scale factor, and scale factor doesn't really affect anything like intercepts and behavior. All it affects is how much the graph stretches. But then the y-axis kind of stretches with it, so we really don't have to worry about that. Um, two horizontal intercepts. Okay, so that's a thing. It does have two horizontal intercepts, right? And those intercepts are going to be at, clearly one of them is -4. And there's another one. Where's the other one? It's at 0. Remember, when x itself is just a factor, there's an intercept at 0. Okay, so those are the only two x-intercepts. But there's only two horizontal intercepts, but it has a degree of 3. Shouldn't there be 3 intercepts? Well, it turns out there doesn't have to be if one of them is a duplicate. And that means that one of these must be a bounce, a multiplicity of 2. And the reason why that we can tell it is it has a degree of 3. So it's got a degree of 3. And so we know it's going to either do that or it's going to do that. Now, do we know that from this case? Okay, it does say its leading coefficient is negative. Okay, so that one's out, and we know we have this. So here's the thing. We know that the graph is going to do this and this. Now, here's the problem. It only has two horizontal intercepts. So I could either pass through the first one, and if I attempt to pass through the second, in order to match the end behavior, I have to bring that graph back down again and cross the x-axis. But that's going to create a third horizontal intercept that I don't want, right? I can't cross this axis again. So the end result is that in order for that to be able to cross and come down, one of these is going to have to bounce. And so we have two situations that can happen here. Let's erase that. Is that I can either come down here and come down, bounce off this one, and come back down like this. I kind of missed the point, but you get it. Or we bounce off the first one. So it could look potentially like that. Something like that. Again, it's slightly missed there, but you get the point. Either one of those works. And so those functions, there are two potential functions that you could have here. And that is, let me erase this part here. You could have two potential functions here. You could have negative x squared times x plus 4, or you could have negative x plus 4 squared. Now, could there potentially be a number in front of this, like -2, -3, -4? Sure, absolutely. And all that would do is change the stretching of this, but would not change any other properties of the graph. So without loss of generality, we'll just leave it at 1. Those are the only two potential types that you're going to see for this graph. So you can see how once we know just one or two factors of the graph, how like all of the properties come together and allow us to draw a picture of what it should potentially look like. Okay, so now let's use the algebra piece of it and kind of put all this together. All right, so what we're going to do is we're going to look at three polynomials. And we'll kind of work them all out. And plus I have a little bonus question at the end. Okay, so as I said before, in order to start the process, we have to know one of the factors. Later on, a few lessons down the road, we're going to look at methods in order to figure out how you could determine what the first factor is. And if I just say, hey, here's a polynomial draws graph, we could do that. But for right now, we need one of the factors to get the process started. And in this case, we have a polynomial, and we're going to start with x minus 3. So our first goal is going to be to find all the rest of the factors. Well, how do we do that? We need to get that factor out through some long division. So let's do that. We have, let's write this down. We have x to the third plus 6x squared minus 13x minus 42. And we're going to divide this by x minus 3. Okay, now keep in mind, I'm going to shift this down a bit. Because we've already done the lessons on long division, 12 and 13, if you need a little bit of a slowdown here on like breaking down which steps you perform in long division, I do recommend that you go back and watch the lesson 12-13 video. But for here, because this is now the third lesson in which we're seeing it, I'm just going to kind of produce this. I'm going to assume that you're somewhat proficient, at least on the long division, and that I'm just introducing the new concept of producing the whole graph. So I'll go a little bit quicker on this video through the long division problems. So remember that our first step is, at each level that we have, we're going to divide by the x. So that's going to produce x squared. So x to the third divided by x is x squared. I then multiply by this, I get x to the third minus 3x squared. Okay. Multiply by the divisor. Change the signs. And add. Remember, changing the signs and add is a substitute for subtraction. 9x squared. Okay. 9x squared, we divide on an x. So that's 9x. bring down the minus 13x, multiply, and I get 9x squared minus 27x. Again, change the signs, and we'll add. Okay. Negative 13 plus 27, that's 14x. Drop down the minus 42, and repeat. Divide by x, and multiply. And as you can see, you get a 14x, you get a minus 42. Change the signs one last time. Beautiful. We get our 0. So we know that that's correct, that that certainly is one of the factors, and that 3 is an intercept. Okay, so now though, what's left over once I've divided out the x minus 3? What I'm left with is this polynomial, of x squared plus 9x plus 14. And can that be written in factored form? Now, yes, we have a process. Remember that now we have a process to break out factors. And that process is what adds to 9, multiplies 14, x plus 7, and x plus 2. All right. So my complete polynomial is the following. It's x minus 3 times x plus 7 times x plus 2. That is a complete factoring of the original polynomial. And one of the things, again, that's important to check, x times x times x, that's x to the third. Negative 3 times 7 times 2, that is negative 42. So that, in fact, does work there. So that's some information to help corroborate, okay? The last thing we need is we need to draw a graph, okay? So I'm just going to take this stuff, shift it over a bit, take this, let's scooch this up a bit. So this is in factored form. Now let's draw a graph. And the graph is as easy as, with this one, graphing the x-intercepts. So my x-intercepts exist at, I have to go back here, negative 7, 3, 4, 5, 6, 7. So we've got one at 7, you've got one at negative 2, and you have one at positive 3. So these are my x-intercepts. Now, what kind of graph is it? Positive odd. So positive odd, it's going to have that kind of shape to it. So it's going to go down and up through the intercepts like this. Kind of like that. And as you can imagine, notice the the y-intercept is negative 42. And sure enough, this graph does cross on the negative. So it looks like we're pretty well situated with that. So that's how this works. Well, let's do a few more examples just to see what happens. And in here, we'll do a couple tougher ones too. Okay. So g of x equals x to the third minus 8x squared plus 11x plus 20. One of the factors is x plus 1. All right, let's take a look. So x to the third minus 8x squared plus 11x plus 20. Let's do our long division, x plus 1. Okay, we're going to divide out the x. That's x squared. X to the third plus x squared. Negative 9x squared. Okay, plus 11x. That's an 11. And you know what? I'm going to write that a bit better. I'm kind of, well, not rushing, I suppose, but I could probably write a little bit neater. Okay, we're going to divide out the x again. Minus 9x minus 9x squared minus 9x. Change the signs. And we're going to add. And this produces 20x plus 20. Divide out an x. And continue. So 20 times x plus 1. 20x plus 20. And at this part, just change the signs. 0. Okay, totally works. But we know it's going to get a remainder of 0, right? We're told it's one of the factors. So why is that important? We still have to do the division. Remember, we need this quotient. Okay, we need the quotient because now the quotient factors, let's see, what adds to negative 9 multiplies to 20. It looks like we are going to have x minus 5 and x minus 4. So my total polynomial is x plus 1, x minus 5, and x minus 4. Okay? Once I have that, again, the graph is going to look very similar to the other one, right? It's an odd positive. And so I'll have roots at 4 and 5. I'll just put some dots here and here. I'll root at negative 1. And it's just going to go up, kind of like that. Easy enough. And the x-intercept, or y-intercept, I should say, certainly matches because it's positive. Right? Nothing too hard there. One more time. 2x to the third minus 7x squared minus 33x plus 18. Now this one's going to be interesting because it's got a 2x to the third. Don't let that bother you when you go and do the division. 2x to the third minus 7x squared minus 33x plus 18. X minus 6. All right, let's take a look. 2x to the third divided by x. That's 2x squared. Uh-oh. That means we're going to have one of these that we're going to have to factor. Oh, that's a lovely one. All right. So expect a bit of a harder time factoring this one. So now we do multiply. We get 2x to the third minus 12x squared. Careful, the 2 does get multiplied there. Okay. Change the signs and add 5x squared. Be careful. It's very easy to get a 19 here, and the 19 will make this very difficult to do. Okay, so you do get a 5x squared minus 33x. Divide by x plus 5x. 5x squared minus 30x. Change signs. Add minus 3x. Bring down the 18. Divide out the x. Multiply. Change the signs. 0. Just like that. Now this. Ooh, so remember this type of polynomial, right? Okay. So these are the ones, because you have the 2 that doesn't divide out, what you end up having to do is you end up having to split the middle term here, okay? So when we do this, good luck trying to find two numbers that add to 5 and multiply to negative 3. You'll never get it. Instead, they have to multiply to -6. So can you think of two numbers that add to 5 and multiply to -6? How about 6 and -1? So do 2x squared minus 6x, or plus 6x minus 1x minus 3. So we split the middle term here to create a polynomial that we can do factor by grouping on. And now we're going to pull out 2x from the first two terms. I know all this stuff is coming back, huh? Like 5 different lessons all rolled into this one problem. 2x. Now we divide out the 2x from here, and that leaves us with an x plus a 3. And on this side, what's a common factor? It's -1. X plus 3. Okay, great. So once you have that, now we can bring these together, and you get 2x minus 1 times x plus 3. There we go. So once you have that, and there's also the magic number shortcut as well. The magic number shortcut does work on here as well. I showed the splitting the middle term way because that one is a little bit more mathematically. It's the same process, but it's kind of more mathematically sound because all these steps are legitimate math operations. So now once we have these factors split apart, all I now have to do is bring in the x minus 6 and here's my factor. Okay. Now in this particular case here, you're going to have, let's see, 6 is going to be an intercept, -3 is going to be an intercept. What about this one, you remember? 1/2 is going to be an intercept here. And so the graph will cross at those 3 spots. So once again, no problems here. It's another odd positive one. These are all odd positives. You'll have an intercept at 6. You'll have an intercept at like 1/2. And then you'll have one at like -3. Something like that. And again, y-intercept's positive. Y-intercept's positive. We're good to go. So this is a really nice process in order to find all the factors using the things that we already know, and allows you to tell all the properties and everything else. But one of the hangups to this is you have to be given that first factor. Okay. And that is definitely important. Like I said, in the future, you may not always be given that first factor. And so the next lesson that we'll do involves a little bit of, what happens when we don't have factors. But more on that after. Okay. One more thing to think about here. Take a look at this polynomial. 3x to the third minus 2x squared minus 15x plus 14. But this time, I'm going to give you two known factors, x minus 2 and x minus 1. Could you write this in factored form? Okay. Now, at first, that might seem easy enough, right? How might you do this? Could you just take a factor and long division it? And then you'll get a result. And you could factor. You could do exactly what you just did, right? Pick a factor. But now here's the thing. There's an interesting to note. Which factor would you pick and do long division with? As you can imagine, it doesn't matter. So let's go back a couple pages here, and let's go back to this one. You have x plus 1, x minus 5, x minus 4, and that multiplied to this polynomial here. We divided by x plus 1, and the result gave us the other two factors. But what would happen if I divided by one of these other factors? So what if I took this polynomial, okay, and instead I'm going to erase. What happens if I erase this, okay? So I'm going to go ahead and erase. Sorry, I just had to find my erase button. I'm going to erase all of this result here. I'm going to erase all of this. I'm going to keep the result here. Let's get rid of the graph. Ooh, that actually worked. I didn't think that was going to work. The circle erase. Okay, so I'm going to try that here. Do the circle like this. I'm going to go around here. Perfect. And that's gone. All right. So I'm going to get rid of all of this. When we did this, the result was x squared minus 9x minus 20. What if I did this? What if I took this polynomial and I divided it by x minus 5? Could you tell me what the result would be without doing the long division? Well, we know we're going to get a remainder of 0 because it's a factor. But that's this factor. If I divide out this factor, what would I be left with? I'd be left with this factor and this factor. But I wouldn't see them up here, right? I would see the product of those two factors. I would see that polynomial, the standard form of that. And so what I'd actually see up here is I'd see x squared minus 3x minus 4. Go ahead and try it. I encourage you to go ahead and try that, and you will find that you do indeed end up with exactly that. Likewise, if instead I divided by, again, let's go back here. If I change this, if I divide it by x minus 4 instead, oops, I would end up with the other two factors. I'd end up with x squared minus 4x minus 5 if I did that. And again, you could go ahead and show that that's true. Because x minus 4 is one factor, then the division would leave me with the other two factors combined together. Knowing that, let's go back to this one. A polynomial has known factors x minus 2 and x minus 1. So if I were to divide out, pick one, right? And I divide out x minus 2. I'd be left with a factor, okay? So let's say I did that. I divided x minus 2, and I divided it into 3x to the third minus 2x squared minus 15x plus 14. What I'd be left with is I'd be left with an answer. And that answer, when factored, would be x minus 1 times something. Now, here's my question. How many factors are missing? It's degree 3. I've got two factors. Degree 3 would have 3 linear factors. So I know that I'm going to have just a single factor. I've got a single x thing missing, right? Okay. Now, here's the thing. We could do that, and you could do the long division. Doesn't matter which one you do. You factor the result, and you'll get it, right? Of course. But now let's say this. You don't have to do the long division on this because you know two factors. You don't. You don't have to do the long division on this. Can you think of a way that you could tackle this and find that third factor without using long division? Okay. I'll give you a hint. Remember that you're only missing one factor. And remember that to determine all the properties of the function, the only ones that really mattered were the first term and the last term. Okay, well, let's see. 3x to the third, what's going to multiply to give you 3x to the third? Well, we've got an x, we've got an x. So what should this term be? This term should be a 3x. Because you can't have anything else, like 3 is just 3, right? And you only have room for one number. Now, how do we know that the 3 isn't on the outside? We know that because not all the numbers are divisible by 3. If this 3 were supposed to be on the outside, all of these would be divisible by 3. And even then, we don't even need, like, you could all be divisible by 3, and you could still have that 3 in there. It would just be that the other number would be divisible by 3 as well. But that's not happening here. What should this last number be? Well, this is the y-intercept, right? And remember, this constant term, this y-intercept, you can get that from the multiplication of all the constant terms. So negative 2 times negative 1 times this has to be 14. And so, because again, we could potentially have another number here, right? And now that I'm thinking about it, we could have a number there which could change that result. But let's find out. Well, negative 2 times negative 1 is 2, right? And then 2 times 7 would have to be 14. Well, let's see if this works. Well, let's multiply the first two, and you have x minus 2 times x minus 1. You have x squared minus 3x plus 2 times 3x plus 7. Okay. All right. Now let's distribute this. 3x to the third minus 9x squared plus 6x. Now we go on to 7. Plus 7x squared minus 21x plus 14. And so we get 3x to the third minus 2x squared minus 15x plus 14. And if I go back to the top, hey, look at that. It matched. Perfect. Now, one other thing I'm going to show you, simply because we have the video here, right? So that was kind of a clever way of figuring out what that third factor is, because we know that they have to, the first terms have to multiply to the first term of the original, and the constants multiply to give you the y-intercept. So that's really what we did to figure that one out. You can, though, use long division on this. But here's a clever trick as well that you can do, okay? If you want to do long division, okay, and again, I'm only showing you this just for those people that, may want a few different tools in their toolbox, right? Okay. So remember that I'm going to divide this. So 3x to the third minus 2x squared minus 15x plus 14. Since you're given two factors, why not do long division and divide them both out at the same time? Well, what? How does that work? Multiply these two together. And remember, x minus 2 times x minus 1 is going to be x squared minus 3x, plus 2. And so you know what? I'm going to put this over here. X squared minus 3x plus 2. Why? We haven't done long division like this. Hang on. Just showing you this. I get it. It's the same exact process. You're still going to divide. But now, instead of dividing by x, we're going to divide by x squared. So what's 3x to the third divided by x squared? Just x. So I'm going to put an x way over here. And I'm going to multiply that x times all of this. I just have 3 terms instead of 2. But it's still the same process. 3x to the third. Now I multiply by that. And now I have 3, so negative 3x squared plus 2x. So the first terms will still cancel out. I still change the signs. Boop, boop, boop. But this time I just change 3 of them and add. Cancels. A single x squared. And here I get negative 15 plus negative 2 is negative 17x. Wait, something didn't work here. Oh, you know what? I forgot a 3. 3x to the third divided by x squared is 3x. Let's back this up a bit. Okay. All right. Made a slight mistake. All right. So should be a 3x. Whoopsie. Okay. So 3x up here, right? 3x times x squared is 3x to the third. 3x times minus 3, it's minus 9 x squared. Oh, that's so much better. And then 2 times 3x is going to give you 6x. Okay. Now we change the signs and add. Those are going to cancel. Negative 2 plus 9 is 7x squared. Negative 15x plus negative 6 is minus 21x plus 14. Now we do 7x squared divided by x squared. That's 7. And now we multiply, we get 7x squared minus 21x plus 14. And everything just zeroes right out. And we get 3x plus 7. So that works too. So you can do that. Either method works. Personally, though, I like the first way better. Like, log division's a fine process, but if you have a way that you can avoid it, it's probably best to do so. I don't doubt that you guys could do the long division. I'm confident in you, but we are human. We do make mistakes, clearly, as I did here. So let that mistake, and the reason why I'm not re-recording the video, even though I made the mistake, is because I want to show you that, yes, we can do it, but it does open the opportunity to make mistakes that we otherwise might not if with a little bit of logical thinking. So part of what I hope to teach in Algebra 2 is not just the processes to do things, but I want to challenge you to expand your brain to find the best, most efficient ways to answer a question. That is a very good real life skill. Are you going to do a lot of polynomial long division in real life? No. So then why teach it? Because I'm teaching you how to think and showing you different ways to think through situations. And that's the best lesson of all. Okay, guys, I'm going to leave it here for this one. Next video, we're going to look at some cases where what happens when you don't have a factor. All the problems we've done so far have a remainder of 0. But what if they don't? All right, until then, take care.